Good afternoon, students. Today we are going to discuss another 10th class topic, classification of elements in the periodic table. So, how the elements are classified and how that present whatever we are seeing that periodic table, how it is came. So, that all the things we are going to learn today. So, first introduction of that classification. So, first Robert Boyle, the basic material of a substance that is an element, was given a definition for that element. So that cannot be decomposed further into the substances, either physical or chemical change. So whatever you are taking the one substance or any material, if you break down to the pieces, that final stage of a particle, that is said as a element. Okay, so that is given by Robert Boyle. So after that, the discovery of the elements are done either synthetical or natural sources. So by this time, there is a 13 elements only is by this time 13 elements only known. After that, Lavoisier discovered the 11 elements. The oxygen gas is discovered by also Lavoisier. So by this time, 11 elements are discovered. Further continues the development of discovery of that elements in the 18th century. Then there is 63 elements are known. So further, the scientists are discovering by the 1940, there is a total 108 elements will be present. In that, 91 is a natural source, 18 is synthetically they prepared in the laboratory. So like this, the elements are discovered. So elements are increased, the number will be increased. So the remembering of that elements and its properties, natures, it is very difficult. So that they decided that we have to need one table, or we have to need one sequence to identify that similar properties of elements. So group of elements, if we together, then we can identify easily. So that they thought that we need a particular table for this all the elements. So first classification is done by Dobereiner through triads. The second classification is done by new lines by taking of octaves. The third classification is done by mostly Mendeleev. Then fourth, mostly periodic table. Dobereiner law of triad. So this is the first classification started by the Dobereiner. So how he was classified? So he is a German chemist. This law of triads is given in the year of 1829. It was taken that the property of atomic weight. He was taken the property of atomic weight. Based on the atomic weights, he was arranged that elements in the increasing order. He was arranged the elements in increasing order. So in this increasing order, he was taken the group of three elements. Three elements he was taken the group. Three elements is he was taken as a group. This group can be called as triads. This group can be called as triads. So how he was given that definition? So how he was arranged that group of elements and what is the triads definition? So first element and third element, weight of first and third element weights average is equals to the second element weight. A first element atomic weight plus third element atomic weight, you can do the average. Then what is the weight will come? That is equal to the second element weight. Based on this formula, he was arranged the three elements. Like simple example, lithium, sodium, potassium. He was taken the example one group is given as lithium, sodium, potassium. So lithium weight is 7, potassium weight is 39, sodium weight is 23. Is it triad or not? We have to check. So based on this, first element weight is 7, third element weight is 39. So it's average. So what is the total here? 46 by 2. Then we will get 23. So this 23 value is equals to the sodium value. So he was given that lithium, sodium, potassium is a one triad. Lithium, sodium, potassium is a one triad. Like this, he was given the groups. But this is not satisfied for more than 20 elements or somewhat more masses or less atomic weights. For example, fluorine, chlorine, bromine. Fluorine, chlorine, bromine. This is one example. So what is the fluorine atomic weight? 919. This is a 35.5. Bromine atomic weight is 80. So cross check it. 19 plus 80 by 2. So this is 8 plus 1, 9. 99 by 2. So what is the average here? 2 ones are 2 fours are 8 plus 1 9. 2 nines are 18. 49.5. 49.5 we are getting. But what is the weight of chlorine? 35.5. Means if you are taken low atomic weights or high atomic weights, it is not suitable for fitting into the triads. So this is a failure of Daubernier triad. Simple. What is the triad? Triad means 3 group of elements will be present. So how he was arranged that elements? Means the average of first and third element atomic weights is equals to the middle element or second element. Like that he was given triads. So this is the example. Okay. So this is about law of triads. Next classification, Newland's law of octaves. So after Daubernier, so in 1865, Newland was tried to given some classification. So based on Telugu tunes, Sa, Re, Ga, Ma, Pa, Da, Ni, Sa. So how the Telugu tunes are repeating of 8th note. So here you can see 1, 2, 3, 4, 5, 6, 7, 8. So how the repeating of 8th note? So like that, if the arranging of elements in increasing order of with respect to of its weights, he was arranged the elements in increasing order with respect to of its weights. How the Telugu tunes are repeated? How the Telugu tunes are repeated? Like that, these elements also will be repeat or periodically it will having the similar properties that he was noted and he was given for that law of octaves. Means what is the definition of law of octaves? So arranging of elements in the increasing order of its atomic weights, the first elements will having the similar properties to the 8th elements. So ante increasing order lo elements ni arrange చేసినప్పుడు ఫస్ట్ ఎలిమెంట్ 8th ఎలిమెంట్ కి సిమిలర్ ప్రాపర్టీస్ ఉండడం అబ్జర్వ్ చేశారు. సో అలా అబ్జర్వ్ చేసి వాటన్నిటిని ఎలా అరేంజ్ చేస్తూ వెళ్ళాడంటే ఫస్ట్ ప్లస్ 8th ఎలిమెంట్ అలా సిమిలర్ గా. ఫర్ ఎగ్జాంపుల్ ఇఫ్ యూ టేక్ ద సెకండ్ ఎలిమెంట్, దట్ 9th ఎలిమెంట్ విల్ హ్యావింగ్ సిమిలర్ ప్రాపర్టీస్ టు సెకండ్ ఎలిమెంట్. సో ఇలా అరేంజ్ చేసుకుంటూ వెళ్ళాడు. కానీ న్యూలాండ్స్ యొక్క సీనియర్స్ కావచ్చు లేదా అతని దగ్గర పనిచేస్తున్నటువంటి స్కాలర్స్ కావచ్చు, వాళ్ళెవరూ కూడా దీన్ని యాక్సెప్ట్ చేయలేదు. కనీసము ఈ పీరియాడిక్ టేబుల్ ని కనీసం ప్రింట్ చేయడం కూడా జరగలేదు అనమాట. సో జస్ట్ he was attempted a classification, but it is not accepted by his seniors or other scientists also. So it is a failure classification, right? After this, the Mendeleev made a wonderful classification of elements. So that we are going to discuss. Right, first Mendeleev periodic table. So first one is what is the property he was taken? So he was taken the property of atomic weight. He was taken the property of atomic weight. This based on the atomic weights, he was arranged the elements in increasing order. By this increasing order, he was systematically arranged. In a chart via table. In a table he was arranged. In this table it is having the groups. In this table it is having the groups and periods. Groups and periods. Sir, what are the groups and what are the periods? So vertical columns is called as the groups. Horizontal rows called as periods. For example, this is a table. Like this the table is arranged. So this is a horizontal. So this is called as a periods. Vertical means top to bottom. So this top to bottom. This top to bottom is called as groups. So in this periodic table, total groups is 8 total periods is 7. Total periods is 7. Total groups is 8. Total periods is 7. Each group again subdivided into two subgroups. Each group is divided into two subgroups. Those are given the names as A and B. Sir, how he was classified or how he was arranged that two subgroups? Means by the reaction of oxygen, this first group elements all it is having the similar formula of R2O. The second group of elements will having the formula of RO. By the reaction of oxygen, he was arranged that which are having the R2O formula, that is belongs to the A group, which are having the RO formula, those are belongs to the RO, that is belongs to B group. So like this he was arranged. By this arranging is done, he thought that maybe new elements will also discover. By that arrangement he thought that maybe new elements will also discovered by the next scientist. So I have to give the some space. So he thought that for that he was given some spaces. And for example, this is empty and this is also given as empty. So empty గా అలా వదిలేయలేదు మళ్ళీ. సో మళ్ళీ ఏం చేశాడు ఇతను వాటికి మేబీ ఏదైనా నేమ్ పెట్టాలి అన్నట్లుగా he was given the names as with eka. He was given the names with eka. Eka is a Sanskrit word. It is a meaning of one. It is a meaning of one. So he was given the names for that eka boron, eka aluminium, eka silicon. Eka silicon. అంటే బోరాన్ లాగా ఇంకొక ఎలిమెంట్ ఉండొచ్చు. నెక్స్ట్ అల్యూమినియం లాగా ఇంకొకటి, సిలికాన్ లాగా ఇంకొకటి. లైక్ దిస్ హీ వాజ్ గివెన్ ద నేమ్స్ ఫర్ దట్ గ్యాప్ ఎలిమెంట్స్. ఫర్దర్ అంటే ఇన్ ద ఫ్యూచర్ దట్ ఎలిమెంట్స్ ఆర్ నేమ్డ్ యాజ్ స్కాండియం, gallium, and this is a germanium. This is a germanium. Okay? What he thought like that there is a by respect of the atomic weights, densities, molecular formulas suitable by these three elements. So this is a great achievement of Mendeleev. And this by this arrangement happened in the table, he was taken another spectacular thing is anomalous pair. Anomalous pair. So what is the definition or what is the meaning? So anomalous pair means, so actually he was taken the increasing order of atomic weights like this, that we have to arrange as per his instruction. So what he was taken the property atomic weight by increasing order. So this is the atomic weights. Think 125, 126, 127 and 128, like that we have to arrange. But unfortunate, he has arranged that atomic weights into 127, 126, 128. So it is not following the increasing order. See that 125, then 127, 126 and 128. So these two elements are not following the increasing order. But he said this is series only, this series only correct. But he was not given that explanation why he was arranged. So this anomalous pair is considered as an achievement as well as a drawback also. So what are the elements is actually means tellurium and iodine. 127.9, 126.7 actually weights. And just example I am giving, like that we have to arrange. But he was taken that 127 is the first, then next he was arranged the 126, means high atomic weight element is taken as the first, then low atomic weight element is taken as a second. But there is no correct explanation for this arrangement, so that this pair is called as an anomalous pair. Next, he was done correction of atomic weights. He was given the correct formula for identifying the atomic weights of the elements. So what is the formula is given? Equivalent weight into valency. Equivalent weight into valency. So generally beryllium Generally beryllium. Beryllium valency actually considered as 3. Equivalent weight is 4.5. So 4.5 into 3. So what is the total here? 5 3 is 15, 4 3 is 12 and 13. 13.5 actual weight. But he was corrected that beryllium equivalent weight is same only. But what it is considered to the beryllium, it is having the 2 valence electrons. So it is a valency is 2 and its weight is 9. Like that he was given the explanation. So like this, beryllium and indium as well as gold. For these 3 elements, he was given corrected atomic weights by using of this formula. So these are all the classification of Mendeleev periodic table. So once again you can see here. So Mendeleev periodic table, he was taken the property of atomic weight. He was arranged the increasing order. So by the systematic arrangement, he was arranged in a table using of groups and periods. 8 groups and 7 periods. Each group is divided into 2 subgroups. Those names as AB with the molecular formulas of R2O and RO. And next, he thought that maybe some new elements will be discovered in the future. So he was given some gaps predicting that new elements. So he was predicted that names like this. But in the future, they are discovered as scandium, gallium and germanium. Next, hedging of increasing order, he was not followed that sequence at a particular of tellurium and iodine. But he was not given that correct explanation why he was taken that. So this kind of pairs we can call as anomalous pairs. And corrected atomic weights, beryllium, indium and gold. So what is the formula he was taken? Equivalent weight into valency. So these are all the achievements or classification of Mendeleev. In this classification also, there is some failures is there that we can say as the limitations. So what are the limitations of limitations? What are the limitations? So first limitation is he was not given correct explanation for anomalous pair. Anomalous pair. The second explanation, second default was taken dissimilar elements. Dissimilar elements are arranged in same group. Next, third one, metals and non-metals are present in same group. Metals and non-metals are present in same group. Example, manganese and chlorine. One is a 7th A and one is a 8th A and 8th B. But these two are present in the 8th group. Manganese is metal, chlorine is a non-metal. So like that, metals and non-metals are present in the same groups. So these are all the demerits of Mendeleev periodic table. So next classification, modern periodic table. So which is classified as given by Moseley, H.J. Moseley in the year of 1930. So how he was classified and what are the postulates and what are the limitations. So that we are going to discuss. Right. So modern periodic table. So previously triads, octaves and Mendeleev. These 3 classifications are majorly based on atomic weights. These are based on atomic weights. But the Moseley time, when Moseley was classifying this table, there is a discovery of atomic number is done. Atomic number. In the nucleus, the total number of protons. Number of protons is considered as atomic number. Then the time X-ray diffraction is done. So based on that, it is a discovery of that protons is done. Then it is considered as atomic number. So the Moseley was taken the property of here atomic number. So it is equal to the number of electrons also. Okay, he was counted as that how many number of electrons. Based on that, he was arranged that increasing the atomic numbers. So this is the basic of classification of Moseley. Right. Next, how he was classified the periodic table. He was also taken as a classification similar to Mendeleev, groups and periods. Groups and periods. This is similar to the Mendeleev also. But here the change is, actually in the Mendeleev it is a groups are 8. It is a further it is a 2 subgroups, total 16. But every group he was considered into the separate group, like that he was taken 18 groups. The same periods, that is 7 periods he was taken. He was taken 7 periods and the groups is 18 groups. Means in the Mendeleev what are the subgroups is there? R2O and RO. Dissimilar elements are 2 or more elements present in the one subgroup. So like that, if it is the demerits is there. So but all it is overcome by the Moseley, and he was taken that every group every element is separate group, like that he was taken the 18. And next, triads is 3, oct means 8. He was 8 groups, so it is included to 16 subgroups. But here the 18 groups is there. Means this is the longest. So this only can be called as long form of periodic table. Based on this reason, it can be called as a long form of periodic table. So why it is called as a long form of periodic table means it is having the maximum number of groups, right? So what is the definition of the groups? That is a vertical columns and the periods is a horizontal column, right? Here he was given each group into one family. Each group is considered as a one family. For this there is a given names also. So first A group, second A group, third A, fourth A, fifth A, sixth A, seventh A, eighth A. So he was classified this periodic table into 2 types actually. First 2 types. So those are A type and B type. Each type having the 8 groups, that is the Roman letters of 1 to 8. Each type having the 8 groups, those are Roman letters of 1 to 8. And next, in Arabic numbers, it is 1 to 18 groups. He was given the classification is 1 to 18 groups, right? So what is a first A group family, and coming to that last up to the 8th A group family. So what are the names? So first group, the name is alkali. Okay, alkali metal family. Alkali metal family. Second one is alkaline earth metals. Alkaline earth metals. So it is starts with hydrogen. Second one starts with beryllium. So third A group is boron, fourth one is carbon, fifth A nitrogen, oxygen, fluorine, and helium or neon we can consider. Okay, so hydrogen or here lithium here, right? So here third A group boron family, and this is a carbon family. This is the nitrogen family. This is oxygen family. This is a halogens. This is a noble gases or inert gases. inert gas. So is there any particular names for remaining groups? So here oxygen family also called as chalcogen family. Oxygen family also called as chalcogen family. Nitrogen family also called as pnictogen family. Pnictogen family. These are actually fluorine family. It is called as a halogens. Okay, so these are the names. These are all the groups are based on its valence electrons. Its valence electrons, based on the valence electrons in the valency shell. He was checked that every group of elements having a similar electronic configuration. Based on that, he was arranged this groups families. Next, coming to the periods. Coming to the periods. How many periods is there? 7 periods is there. So 7 periods having how many number of elements from where to where, and how many number of elements will be present. So first period, second, third, fourth, fifth, sixth, seventh. So these are the period numbers. So first period having 2 elements. First period having 2 elements. It is having number of elements is 2. Number of elements is 2. Second period having 8. Third period also having 8. Fourth is having 18. Fifth is having 18. Sixth is having 32. It is having 32 elements, but we can consider it is an incomplete period. Incomplete period, right? So based on this, we can give the one statement here. So first group elements, so first period elements are the shortest. First period also called as shortest period. Second and third periods are called as short periods. It is called as short periods. Fourth and fifth long periods. Sixth period is longest period. Sixth period is longest period. And next seventh one is incomplete period. From where to where the elements? Here the 2 elements will be present. So that elements is the first one is hydrogen to helium. Hydrogen to helium. Like that, this group of elements having also having the second group will starts with lithium. Third group sodium. Fourth potassium. Hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. These are all the starting elements of periods. The periods can be starts with these elements. Next, periods will end with what are the elements? Helium, neon, argon, krypton, xenon, radon, organs. Right? So these are the starting and ending elements. Sir, what are the atomic numbers? What are the atomic numbers? So simple method. The atomic numbers finding అనేటువంటిది చాలా సింపుల్ ఇక్కడ. So ఎలా find out చేయొచ్చు? Already everybody will know hydrogen atomic number as well as helium atomic number. Right? So this is the first period, so that you have to add the 2. Then the lithium atomic number will come. After this, how many elements will be there? 8 elements will be there. So you can add the 3 plus 8, that is the atomic number of 11. Okay, we are adding here 8. Sodium after 8 elements will be present, so that we can add the 8, you will get 19. Then after how many elements will be there? 18. So you can add the 18, that is the atomic number of 37. Then add the 18, 55. Okay, then after 32, 87. These are the atomic numbers of our starting elements. Next, coming to the ending elements, 2 plus 2 completed. So 2 completed. So after 3, there is how many elements? 8 elements will be present. Means second period having the 8 elements. For that last elements you have to add. You will get 10, 18, 36, 54, 86, 118. 118. So total periodic table having now how many number of elements here? 118. 8 elements will be present. And the maximum elements can be classified or arranged in the periodic table by H.J. Moseley. So this is the construction or explanation of a long form of periodic table. So once again you can see here the simple method. So modern periodic table, it is given by the H.J. Moseley. He was taken the property of atomic number. So why he was taken that? At this time there is a number of electrons and number of protons are identified and both are numbers are equal. So based on that he was given the groups and periods. For this classification he was taken or he was given one periodic law. That is important. He was given one periodic law. So what is the periodic law? What is the periodic law? The physical and chemical properties. The physical and chemical properties. Physical and chemical properties of the elements are the periodic functions of its atomic number. ఇక్కడ ఏం చెప్తున్నాడు అంటే వాటి యొక్క ఫిజికల్ అండ్ కెమికల్ ప్రాపర్టీస్ అనేటువంటివి రెగ్యులర్ ఇంటర్వెల్స్ లో వాటి యొక్క అటామిక్ నంబర్ తో రిలేటెడ్ గా ఉంటాయి అనేటువంటి చెప్పాడు. సో బేస్డ్ ఆన్ దట్ హి వాస్ క్లాసిఫైడ్ దట్ గ్రూప్స్ into the same family with similar properties, and it is by adding that one electron to that before elements, he was arranged the left to right that the period elements, and each period having the how many number of elements, what are the starting and what are the ending elements. And next, based on this classification, he was given that next SPDF blocks also, means his periodic table classified. Okay, this is happened. Next, another the classification and included the classification is SPDF blocks that we are going to discuss now. So in this chart he was arranged the 118 elements. So how he was arranged? So he was arranged the elements in the 4 blocks. So what are the blocks? One is a S block, P block, D block and F block. So previously we discussed that is a groups and periods, 18 groups and 7 periods. Next he was classified that classification is in 2 types, A and B. So those are represented here. See here, Roman letters 1, 2, 3, 4, 5 to 8. So this P block elements and S block elements are considered to the A type. The total D block elements are considered to the B type. So where is the location of this period blocks? So S block will be present at left side of the periodic table. So S block will be present at left side of the periodic table. And next, where it is the location of P block? So this is the left side, means it is considered as a right side. So P block will be present at right side of the periodic table. So where is the D block elements? It is middle of the S and P block. So middle or between S and P block, between S and P block. So where is the F block elements? It is the bottom of the periodic table. So it is bottom of periodic table. So right, so S block will be present at left side, P block is in the right side, D block in middle of that periodic table or between of S and P, and F block will be present at bottom of the periodic table. So this is the arrangement. Next, so how many groups are present with respect to of that blocks? So S block will having 2 groups. Sir, how you can say it is having only 2 groups? While checking of its configurations, electronic configuration. So its atomic number is 1, its configuration is 1s1. Lithium also having the configuration of 1s2, 2s1, 1s2, 2s1. So it is also having the 1 electron and it is also having the 1 electron in the valency shell. So these are all considered as a 1a group. Beryllium, it is a 1s2, 2s2. In the valence shell, it is having the 2 electrons. Magnesium also you can see 1s2, 2s2, 2p6, 3s2. In the valence shell, it is also having 2 electrons. Beryllium also having the 2 electrons. So that this second A group elements will having the 2 electrons in its valence shell. Next, S is having the 1 and S is having the 2. And S block having the only maximum number of groups is only 2 groups. Those are first A group and second A group. Next, coming to the P block. So P block elements are boron. So what is the configuration here? Boron configuration. What is the atomic number of boron here? 5. So 1s2, 2s2, 2p1. The valence electron enter into the p orbital. So the p block elements can start from boron. Next, carbon is p2, nitrogen p3, oxygen p4, fluorine p5, neon p6. Its configuration is ns2, 1s2, 2s2, 2p6. So maximum number of electrons in that neon is p orbital is 6, and it starts from p1 to p6. So total 6 elements will be present here. So that p block will having the total 6 groups it is having. P block will having the 6 groups. So that we wrote here general configuration is S block elements configuration is ns122. The first shell aithe 1s1, second shell aithe 2s1, third shell aithe 3s1, 4s1. Next, this is taken as a second electron. Similarly here also. So 2s2, 2p2, 2s2, 2p3, like this it will come. Means the shell number will be same. So that we are given the configuration. General configuration of P block elements is ns2, np1 to 6. Coming to the D block. What is the scandium here? What is the atomic number here? 21. So what is the configuration? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. So the valence electron enter into d orbital. So that the D block will be starts from a scandium, that is the third B group, to it is end with the first B, that is the zinc. What is the atomic number here? It is a 21. So total 10 elements, that is a 30. So what is the configuration? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. So 10. See here up to 10, 20 plus 10, 30. So D block is here closed. Next it will start the P block. So that up to D having the 10 electrons. So the D block will having the 10 groups with a B type. F block elements 58. It starts with 4f electrons. 90 atomic number. There is a 5f. It starts from 5f1. So these are actually presented. These are actually presented in the position of this is a which group? Third B group. That is a third B group. So that these lanthanides are presented third B group, and it is related to which period? 6th period. So it is a third B group and 6th period. Coming to the 5F. 5F where it is here. So it is also presented third B group. So this is the position of third B group and 7th period. This is the position of 4f elements and 5f elements. So what is the names of this group of elements is lanthanides and actinides. 4f block elements, 4f group elements also called as lanthanides. 5f block elements also called as actinides. What is the location or what is the position or where it is located? Means 4f elements be located at third B group and 6th period. Actinides are present at third B group and 7th periods. Next, S block and P block together can called as representative elements. D block is called as it is a transition elements. It is called as transition elements. F block can be called as, see here, F block actually presented inside of the D block elements. But why it is placed here? if these elements are kept here, this configurations will comes under F. But actually in the previous two periods having the configuration of D. So it will be mismatch. So that Mendeleev kept as these all the F block elements into the bottom of the periodic table. But actually these are placed inside of the D block. So this can be called as a inner transition elements. Inner transition elements. So this is regarding a periodic table. See here how many total number of groups here? 18 groups. So that this is can be called as a long form of periodic table. So this is the classification. And if they asked to write the SPDF blocks, explain the SPDF blocks, means you have to write this 4 blocks. So how should we write? So first one you have to write where it is located and definition. The valence electron enter into s orbital. The valence electron enter into s orbital. That can be called as S block elements. If the valence electron is enter into the p orbital, that is a p block elements. If the valence electron enter into d orbital, d block elements. If it is a f orbital, f block elements. This is a definition. Next point, where it is located. S will be located at S, left side. P is the right side. Between S and P, D block, bottom of that D block. Next, what is the general configurations? That also have to write. Next, what is the final point? S and together P is called as a representative, D is a transition, F is a inner transition elements. So where to where? Might be in the bits there is a chance of 4F elements, where to where, what is atomic numbers, that is 58 to 71, 5F is 90 to 103. So this is regarding SPDF blocks and construction of a long form of periodic table.